Good evening and welcome to Unacademy's YouTube live classes. I am Rashmi Amma, welcoming you all to alcohols, phenols and ethers. Students, we have already learned alcohols and phenols, okay, nomenclature, classification, nomenclature, preparations, reactions. Now we started with the ethers, classification, nomenclature, preparations we started, okay, and that two methods of preparation we are learning. First method is dehydration of alcohol in the presence of concentrated sulfuric acid at 413 Kelvin. Okay, this we have studied last class. Today, from Williamson's ether synthesis, we are going to start preparation. We are going to complete the preparation and we are going to start with reactions. Before I start, okay, let me tell you about Unacademy Plus class. If you want to join, if you want to have comprehensive batch, physics, chemistry, mathematics, biology, or physics, chemistry, biology. If you want to have a comprehensive batch, because you have competitive exams, okay, Karnataka CET, JEE, NEET, any competitive exams, you have now all the subjects to write exam for, is it not? Physics, chemistry, mathematics, biology. So if you want to have a comprehensive batch, okay, you have to subscribe to Unacademy Plus classes. Now, there is also a platform called Unacademy Special Classes where you will learn for freely each subject separately. But if you are in a connection with the teacher who is teaching in the Unacademy Plus platform, then you will get to know. For example, myself, okay, I will be teaching in Unacademy Plus classes, chemistry classes for free. So if you get the link through various social medias, okay, you can come to the classroom and learn. Okay, students, you are the ambassadors. If you get the link, share to your friends, your classmates, your batchmates, your schoolmates who are in PUC, first or second PUC, so that they can also come and learn. Or else, if you want to have a comprehensive, there in those platforms you're learning only chemistry. But if you want to have comprehensive all the subjects which you're going to write exam in, if you want to have a complete syllabus preparation, complete study, okay, with an affordable price, you can subscribe to Unacademy Plus class. You can subscribe for 12 months, 6 months, even as a trial period of 1 month. If you are subscribing for 12 months, you are paying 12,375 rupees. That amounts to 1,031 rupees per month. Only 1,031 per month. Or if you are subscribing for 6 months, you are paying 10,125 rupees. That amounts to 1,688 rupees per month. Or you can go for a 1 month trial period by paying 2,250 rupees. Students, if you use my referral code Rashmi 2020, okay, RASHMI 2020, you will get in this amount 10% reduction. That means per month it will be less than 1,031 rupees. It will less than 1,000 rupees in fact. If you use my referral code Rashmi 2020, all capital letters, you will get 10% reduction. Okay, so use my referral code. Whenever referral code is asked, use the code Rashmi 2020. So you'll get all the benefits, okay, of that user code. Okay, what else is the highlights of this batch? One is structured live courses with the dedicated live doubt clearing sessions, entire syllabus. It's not just NCERT. Syllabus for your competitive exam will be dealt there. One syllabus is covered completely, okay, well taught after syllabus. You will be trained to answer MCQs. So you have quizzes, test series, daily practice problems, full length mock test, which will help you in self-analysis. Okay, it will prepare you for exam, also will help you in self-analysis. And you realize when you're answering MCQ, some chapters is not clear, or in chapters certain concept is not clear. So you have, with the one single subscription, unlimited access to Unacademy Plus classes. So you can go ahead, if that chapter is being taken up by other teacher, or during the subscription time, if other teacher is taking that class, you can go attend those classes, or recorded classes will be there. Okay, the same teacher which you used to attend, that same teachers, the same class will be recorded, it will be there. So you can go and access that class, again relearn. So with a single subscription, you have unlimited access to online class, also offline recorded classes. Okay, so use my referral code, get full benefit, and join the class and start preparing. Okay, early preparation will help you a lot. Okay, any doubt, clarification, you can chat to me. Okay, you have chat option. You can ask me your doubts and queries. Okay, yes. Yes, let's start with Williamson synthesis. See, it's actually famously called as Williamson's ether synthesis. But if the question comes, it will come as Williamson synthesis. They will not give you the word ether. That means it's understood, is it not? So it is Williamson synthesis. So what you have to first understand in Williamson synthesis. What is Williamson synthesis? It's a method of preparation. It's a method of preparation of ethers. Okay, ethers. Okay, usually symmetrical ether is best for symmetrical ethers. Symmetrical ethers. Okay, yes. Now, how do you prepare ethers from Williamson synthesis? Reaction of alkyl halide. Okay, reaction of alkyl halide with the sodium alkoxide. What is alkoxide? RO minus is alkoxide. See, alk oxide. Okay, and sodium. Because O minus, sodium ion is there. So sodium alkoxide reacts with alkyl halide, you will get ether. Now, what is the criteria you should know? So you should know sodium alkoxide react with the alkyl halide. Alkyl halide reacting with sodium alkoxide. Now the alkyl halide has to be primary. If you want ether, it has to follow SN1 mechanism. What is SN1 mechanism? Primary is more reactive than secondary than tertiary. This you have learned. Okay, in SN1 mechanism, primary alkyl halide, okay, reacts with the nucleophile, where nucleophile attack the alkyl halide in a single step. So the bond between alkyl and halide breaks. A bond between nucleophile and alkyl group forms like this in a single step. Okay, so this bond completely breaks. This bond completely forms. You get RNU. RNU. Now the NU, that is the nucleophile here, is alkoxide ion. This is the nucleophile. Since this is the nucleophile and you want alkoxide ion, taking up alkyl group of alkyl halide, and you want alkyl halide to come out like that. So sodium and halide ion will form NaX like this. So alkyl halide, alkyl group of alkyl halide and alkoxide ion will join to give you ether. If you want ether, you want the reaction to follow SN2 mechanism. And you remember, in haloalkanes you have learned SN1, SN2 mechanism, is it not? In SN2 mechanism, which alkyl halide follow SN2 mechanism? Primary. So you have to have alkyl halide primary. It's as simple as that. You don't have to have any confusion. Remember your haloalkanes. Remember your SN1, SN2 mechanism. And in SN2 mechanism, primary alkyl halide will follow in a single step to give you product, nucleophile attack. Since the nucleophile is alkoxide ion, your nucleophile, alkyl halide has to be primary if you want to follow SN2 mechanism. So Williamson's ether synthesis, if it follows SN2 mechanism, you will get ether. So you have to take alkyl halide primary. So alkoxide ion can be primary, secondary, tertiary, it can be anything because it's a nucleophile. It can be primary, secondary, tertiary. But alkyl halide has to be primary. Only alkyl halide is primary. It will follow SN2 mechanism. The product will be ether. Product will be ether. Okay. So for example, I hope this is understood. This is in general. For example, alkyl halide, ethyl bromide, see, primary. Primary. It's a primary alkyl halide. Correct? Primary alkyl halide. Yes. Now, primary alkyl halide reacts with the sodium ethoxide. It's also primary, I've taken. So what do you get? This is the nucleophile. Living group is Br. Br will come out. So nucleophile O minus will take up ethyl group. You will have diethyl ether. This is your ether, diethyl ether. Plus NaBr. Salt will be the byproduct. Okay, both are primary. Okay, secondary example I have taken. Your alkyl halide is still primary. Here I have taken tertiary. See, nucleophile is tertiary. Tertiary I have taken. Okay, tertiary butoxide. Sodium tertiary butoxide is the name. See, sodium tertiary, this carbon to which ON minus is attached, intern attached to 3 other carbon atoms. So it is tertiary. Altogether 4 carbon atoms. So butoxide. Sodium tertiary butoxide. Reacts with primary alkyl halide, methyl bromide. What do you get? Again, sodium and Br will form NaBr. Okay, what happens? O minus will take up CH3, or you can remember Br minus, that is one nucleophile. One nucleophile. Okay, 1 second, students. Okay, one nucleophile is replaced by another nucleophile. So nucleophile is substitution reaction. So CH3 is there instead of Br. You have tertiary butoxide replaced. You will get ether. You will get ether. Ether is the product. Okay, so still here primary, this is tertiary. Now, here actually I had stopped and I told you what happens if you take tertiary alkyl halide. So, as long as your alkyl halide, this is alkyl about alkyl halide. If the alkyl halide is primary, substitution reaction predominates over elimination reaction. So, substitution takes place, SN2 mechanism. Okay, SN2, substitution nucleophilic bimolecular will take place. You will get ether. Ether is the product. So, as long as alkyl halide is primary, nucleophilic substitution reaction will take place following SN2 mechanism. Ether is the product. If alkyl halide is tertiary, elimination predominates over substitution. Elimination reaction predominates. See, for example, I will take simple alkyl halide like this, ONA. Okay, of course, this has to be, yes, minus plus. Okay, ionic bond plus CH3, CH3, Cl. Okay, so this is your tertiary alkyl halide. I have taken tertiary alkyl halide. Okay, this is your primary alkoxide. Primary alkoxide. Now, so what happens here when you have like this? Let me show one CH3 group like this. Okay, so when you have tertiary alkyl halide, elimination reaction predominates. This group will come out, leaving group. Okay, so carbocation will form. So one hydrogen will come out as H plus. The bond between the carbon hydrogen will come between the carbon. The carbon which is losing Cl and the carbon which is losing hydrogen. The electron will come between those two carbons, giving you CH3, CH3. This is intact. See, this part is intact. And double bond CH2. You get an alkene. So what happens to your alkoxide? O minus will take up H plus, giving you CH3OH. Okay, so sodium and the Cl coming out group, leaving group, forms NaCl. So you get an alkene and an alcohol and a salt. So this is it. This is the product you get. Okay, so you don't get substitution reaction. You get two products because elimination predominates. So this is what happens if you take tertiary alkyl halide. If you take tertiary alkyl halide, okay, elimination reaction predominates. Or substitution will not take place. See, the Cl group leaving as Cl minus will not be substituted by the alkoxide ion. Okay, what happens? Another H plus will be eliminated. Cl is eliminated, H plus is eliminated. Dehydrohalogenation takes place. Elimination reaction takes place. Dehydrohalogenation reaction, in other words, is called as elimination reaction. See, elimination reaction takes place, alkene you get. Okay, H plus is taken up by alkoxide ion, which is there in the reaction mixture. So alkoxide ion will take up H plus, will give you alcohol. So Na plus and Cl minus will give you NaCl. So elimination product, alkene you get. So alkene is formed due to elimination, beta elimination reaction, dehydrohalogenation. Again, this you have learned in your haloalkanes chapter. Okay, this is what happens. So remember, in Williamson's ether synthesis, okay, if you want Williamson's synthesis ether to be product, so it should carry out SN2 mechanism. So alkyl halide is primary. So substitution takes place. If you take tertiary alkyl halide, elimination reaction, dehydrohalogenation reaction or elimination reaction will take place. Okay, beta elimination reaction will take place and you get alkene. Since alkoxide ion is also there, alkoxide and sodium ion is there in the reaction mixture, alkoxide will pick up a proton, giving you alcohol. Sodium will pick up Cl minus, giving you sodium chloride. Okay, elimination product is the major product here. I hope you understood. So this is Williamson's ether synthesis. So if question comes, explain Williamson's ether synthesis. Explain Williamson's ether synthesis. Okay, just explain will come. Just explain. Then this is the answer you have to write. With an example, if comes with example, then you have to write this. You did not write this now. Since example, particular example you have to write the names, product name. You can write it in words and write the equation, or write the equation, then each reactants and products name. Left hand side reactant, right hand side products are there, no? Write names. That is called a self-explanatory equation. So either you explain then write equation, or write equation and write the names. That is called a self-explanatory equation. You can write. Okay. That is if you want to explain Williamson's synthesis with an example it comes. Or sometimes predict the product, the question will come. Sometimes no, they will give you this too. and what is the question mark they'll give you. So look carefully at the reactants, sodium alkoxide and alkyl halide, and check alkyl halide primary. So write ether. So you replace Br with the alkoxide ion, and sometime predict the product. This will come. See, look at this. You have sodium ethoxide. See, CH3 CH2, and with the tertiary butoxide. What is the product will come? What is the product like this will come? Look at this. Sodium alkoxide, and you have tertiary alkyl halide. Tertiary alkyl halide. So now you should think elimination reaction is taking place. That means the carbon to which Cl is attached. This is alpha carbon. So from beta carbon, alpha carbon Cl will come out, beta carbon hydrogen will come out. And between those two carbon, double bond, alkene. And because proton is coming out, alkoxide is there, you also get alcohol and salt. Depending upon how many question marks are there. So main two products are these two. Sometimes only 2 question marks will be there, sometimes 3. 3 means sodium chloride also you write. Okay, this has to be written. Sometimes predict the product question will come for 1 mark, 2 mark. So 2 is asked, then it's 2 marks will come. Okay, so look at the question and answer. I hope you understood. Okay, now there completes the preparations of ethers over. Now chemical reactions of ether, where you know ethers are ROR bonds. That is carbon oxygen bond is broken. How carbon oxygen bond is broken? In the case of symmetric ethers. See, this is a symmetric ether, is it not? Both are R's. It's like CH3O, CH3. Symmetric ethers. Okay? Okay, let me write it there. CH3O, CH3. Symmetric ether. If I draw a line, I have same equal number of alkyl chains. Symmetric ethers. Okay. First reaction is a reaction of symmetric ether with the halogen halide. Hydrogen halide. HX, HCl, HBr, HI. Okay. Hydrogen halide. What happens? Okay, RO bond breaks. Okay, you have alkoxide ion and alkyl group. The alkyl group, okay, here H plus X minus. Your alkoxide ion will take up H plus, forming alcohol. So alkyl group, see, it is minus, is it not? And this is plus. See, carbon oxygen bond here. If I have to show you properly, it should be like this, CH3. So let's say carbon oxygen bond breaks. Oxygen is more electronegative, it forms minus. So when it reacts with HX, H plus X minus. So O minus will take up H plus logically. Correct? No. So what do you get? CH3, OH, alcohol you get. And X minus and this will be plus. Correct? Bond breaks, oxygen is more electronegative, so it takes up all the electrons, CH3. So carbocation will be picked up by X minus. You will get CH3X. So first step, you get mixture of alkyl halide and alcohol. And the alcohol formed continue reacting with the hydrogen halide. Alcohol formed continue reacting with hydrogen halide. Again, the bond is between R and O breaks, carbon oxygen breaks. So you have oxygen is more electronegative, OH minus and R plus. Here plus minus. Now mix them. So OH will take up H forming water. R plus and X will form alkyl halide. So you get 2 molecules of alkyl halide. So a molecule of ether when reacts with hydrogen halide, hydrogen chloride, hydrogen bromide, hydrogen iodide, when it reacts with hydrogen halide, you will get 2 molecules of. So you can write, directly you can write like this. Instead of writing like this, okay, you can directly write 2 molecules of alkyl, that is CH3X plus water, like this. 2 molecules of alkyl halide. So the symmetric ether, product is alkyl halide and water. But reaction takes place in 2 steps. So alcohol also reacts with hydrogen halide. Okay, this happens in drastic conditions. Okay, drastic conditions. Okay, so symmetric ether reacts with hydrogen halide, giving you alkyl halide in 2 steps. I hope this is understood. Okay. For example, now one example I give you the ethyl, methyl ethers. If it is ethyl ether, okay, CH3OCH, C2H5OC2H5. Again, you will get 2 molecules of C2H5Br plus water. Okay, now why do you get CH2Br? Because it follows SN2 mechanism. You have SN2 mechanism. It follows. Okay, so both the reactants are there in the same step. Both the reactants. So bond between oxygen and carbon is broken, and bond between Br H and Br is H and O is formed simultaneously. So it follows SN2 mechanism. What is SN2? Nucleophile substitution bimolecular. So both the reactants are there in the slowest step. See, both the reactants are there. So you will follow the reaction SN2 and primary. Okay, primary alkyl halide. Okay, what happens if it is unsymmetric ethers? What happens in the case of unsymmetric ethers? For example, CH3O C2H5 with HI, let's say, and the product is CH3I plus C2H5OH. This is the product. See, the bond breaks like this. Okay, bond breaks like this. More number of alkyl group, okay, that forms alkoxide ion, which will take up H plus, forming alcohol, and the smaller alkyl group will take up I minus, forming alkyl halide. So you get two products. So if it is a symmetric ether, you have only one product, your alkyl halide. If it is the unsymmetric ether, you have two products, alkyl halide and alcohol. That means the reaction stops at first step. See, alkyl halide and alcohol. If it is unsymmetric ether, like this unsymmetric ether, reaction stops at first step. So you have alkyl halide and alcohol. Now I'm telling you which forms alcohol. More number of alkyl group. The bulkier alkyl group forms alkoxide ion. The bulkier alkyl groups, okay, forms alkoxide ion. That will take up alkoxide ion, O minus, will take up H plus, forming alcohol. Smaller alkyl groups, or in words, otherwise you remember, smaller alkyl groups will take up halogen ion, forming alkyl halide. So alkyl halide will be the less number of R group, less number of carbon atom in the R group. So this is the product. So smaller alkyl groups forms alkyl halide. Smaller alkyl group forms alkyl halide. That is how to remember. See, these two. Smaller alkyl group forms alkyl halide. See, only one step. Bulkier group forms, see, phenol. Reaction stops here in the case of unsymmetric ethers. This is alkyl aryl ether is an unsymmetric ether. Unsymmetric ether. Correct, no? Unsymmetric ether. So you will get only one step reaction. You will get two products, alcohol and alkyl halide. If it is phenyl group is there, then you get phenol and alkyl halide. That is the product. I hope you understood. So I'm repeating once again. If both R groups are same, then it's a symmetric ether. Symmetric ether undergoes the reaction in two steps. Okay. First, alkoxide ion will pick up H plus, giving you alcohol, and carbocation will pick up X minus and give you alkyl ion. Thus formed alcohol reacts further with the hydrogen halide, giving you a second molecule of alkyl halide and water. So the end result, end product is ROR, because alcohol will get cancelled with each other. Plus 2 molecules of HX will give you 2 plus water. This is the end result. Okay, overall results. Okay, that is the case of symmetric. If it is an unsymmetric ether, what will happen? And in the case of unsymmetric ether, only one reaction, you get alkyl halide and alcohol. That is only the first step. You get alkyl halide and alcohol. And which R group forms alkyl halide? Between the two alkyl groups, the smaller alkyl groups forms alkyl halide. So the bulkier one will form alkoxide ion. So that will form alcohol. I hope you understood. Okay? Yes? Okay. That about, if in the case of symmetric, unsymmetric. Now another reaction I'm going to show you where ether has a tertiary carbon. See, tertiary carbon. What happens if you have two different alkyl groups? Okay, two different alkyl groups. I've told you if it is both are primary. See, this is primary, is it not? When I gave you example, both the C2H5 and CH3 both are primary, right? Now what happens if you have a highly substituted alkyl group like this? See, highly substituted. This is a highly substituted. This is a simple alkyl group, whereas this is substituted alkyl group. What happens if you have two different alkyl groups? In that one is highly substituted. Will smaller one will give you alkyl halide? See? No. In this case, the smaller alkyl group will give you alcohol. Alcohol. Smaller alkyl group will give you alcohol because SN1 mechanism is followed. Till here it is SN2 mechanism. Whereas here SN1 mechanism, because you have a tertiary carbocation here, when oxygen on a carbon bond breaks, Oxygen being more electronegative, it takes the electron, so it becomes O minus and plus. And the carbocation formed, what is the importance of tertiary carbocation? Is more stable. Since it is more stable, it will follow SN1 mechanism. Through SN1 mechanism, okay, that will absorb I minus. I minus will attack the tertiary carbocation. So you will get tertiary alkyl halide. Tertiary alkyl halide, because it follows SN1 mechanism. So the substituted alkyl group, because it follows tertiary carbocation, when this bond breaks, okay, the importance here is when this, see, you question what happens if this bond breaks. Okay, you have primary carbocation, see, this is primary, and no substituted alkoxide. But if this bond breaks, you have a tertiary carbocation. This is more stable than primary carbocation. Which is more stable? If this bond breaks, you have a primary carbocation. If this bond breaks, you have a tertiary carbocation. Among these two, which is more stable? Without question, tertiary is more stable, because you have learned reaction intermediates. Tertiary carbocation is more stable than secondary than primary. So tertiary and secondary is more preferred. So if this bond, carbon-oxygen bond breaks, tertiary carbocation is formed, more stable. And remember, haloalkanes, haloarenes, tertiary carbocation means which mechanism is followed? SN1. That will form alkyl halide. So this will be your alkoxide ion forms alcohol. That has to be remembered. So you have to remember, students, when you have CO bond, remember the main heading of this, see, CO bond breakage, CO bond breakage. Now if you can break a bond, CO between CO bond, there are two CO bonds, okay, but between these two, one second, let me erase this so you can see here properly. Between these two there is a CO bond, and between this CO bond like this. Which when break you get primary, tertiary. Only in this case you get tertiary. So tertiary means that will form alkyl halide. So the primary alkoxide ion will form alcohol. I hope you understood this. So this is very, 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 very important. Okay, again, predict the product will questions will come. Usually from this, see these type of reactions, see cleavage, these reactions, predict the product question will come. Okay, in the case of symmetric ether, what happens? It's very easy. 2 molecules of alkyl halide is obtained, but in the remember 2 molecules of alkyl halide, 2 steps. Because alcohol is also the first step, get alkyl halide and alcohol. Second step, alcohol thus formed is converted into alkyl halide. So 2 alkyl halide, symmetric. If it is unsymmetric, but the alkyl group is primary, okay, alkyl group is primary or primary and aromatic, if that is the case, only one step reaction, you get alkyl halide and alcohol. See, in the first step only alkyl halide and alcohol, correct? No? So same thing happens. Now you remember, since it is both are primary alkyl groups, okay, the smaller alkyl group will give you alkyl halide. Smaller alkyl group, alkyl halide. Okay, smaller alkyl group will give alkyl halide. But in the case of unsymmetric ethers, but if the alkyl group is tertiary, both are no unsymmetric only. This is unsymmetric ether. But if the one R group is tertiary, then that CO bond is broken and the tertiary carbocation will take up C plus, okay, that will take up I minus, forming you tertiary alkyl halide. Tertiary alkyl halide is formed. So remaining will form alcohol. So you have to remember this. Now we were talking about alkyl halides, is it not? Alkyl, this is reaction between hydrogen and halides. Now which hydrogen halide is more reactive for these reactions? Okay, hydrogen halide. Hydrogen iodide is more reactive than hydrogen bromide than hydrogen chloride. Because here, in the case of hydrogen iodide, the energy to break this bond, it should form proton and I minus. So less energy required, readily ions it form, readily reaction will take place, is it not? And because of the bulkiness of the I minus ion and small I plus H plus, okay, this overlapping is not great, the greater extent. Since overlapping does not take place between smaller proton and a bulkier iodide ion, this bond and dissociation enthalpy is very, very less. So bond dissociates enthalpy less, more, even more. Okay, because bond dissociation enthalpy, that is the energy to break this bond, is less, easily H plus ion is released and I minus ion is released. That is why hydrogen iodide is more reactive. Okay, because H plus ion. See, if this bond doesn't break, HX bond doesn't break, you will not have H plus and X minus ion for the reaction to take place. You should immediately, the hydrogen iodide should immediately form H plus and I minus. How when it does form immediately? When this energy to break this bond is less. When this energy will be less? If this is I, because of the big I minus and the small H plus, orbital doesn't overlap effectively. So the bond is very weak, so less energy is required to break. So hydrogen iodide is more reactive than hydrogen bromide, which is more reactive than hydrogen chloride. Hydrogen fluoride reactions are not discussed because reactions involving hydrogen fluorides are explosive in nature. Okay, very vigorous, and they explode in laboratories. You cannot conduct the reaction. Okay, so among these we can use. So hydrogen iodide is more reactive. I hope you understood. Do you have any doubt? Do you have any doubt? Yes, you have any doubt? Okay, in the next class, students, we will discuss electrophilic substitution reactions of ethers. Okay, so this is second reaction. So first reaction was reaction with the hydrogen halide. Is it not? Hydrogen iodide, hydrogen bromide, hydrogen chloride. Okay, second reaction we are going to learn under the heading of electrophilic substitution reactions. Electrophilic substitution reactions of ethers. Okay, we are going to learn halogenation, we are going to learn nitration, Friedel-Crafts reactions. Under Friedel-Crafts reactions, we are going to learn alkylation and acylation. Alkylation, acylation, nitration. Okay, after that nitration, there completes our reactions of ethers. Then we will learn, this is very, very important, more often than not, 1 mark, 2 mark question comes from acidity of alcohols and phenols. We will discuss acidity of alcohols and phenols in the next coming classes. Okay, so today's class I will stop here. I hope you understood Williamson's ether synthesis. Okay, under different what happens, two reactants, what happens if we take different types of reactant. Okay, same reactant but different class among them. What happens? Also reactions between CO cleavage. What happens if we take symmetric ether, unsymmetric ether with the primary alkyl groups, and unsymmetric ether with the tertiary alkyl group. So what kind of products are formed? I hope you understood. Any doubt, reach out, ask question. Okay? Yes. Okay, thank you very much, students, for being a wonderful audience. Okay, thank you very much. Okay, meet you in the next class. Okay? We'll continue with the further reactions. Bye, students.